Okay, so video number 4 for chapter 13, we are going to talk about concentration. Now, concentration can be calculated quite a few different ways. Concentration means how much solute per that solvent, okay? So when I'm dealing with like acids or something in class or somewhere to spell it on them, I'd want to know, hey, what concentration was that? What molarity was that acid? That'd be a big one that we use a lot is molarity. So that's one of them. I could go with molality. We just don't use it as often, and I'll explain why. Dilution will give us some of those molarities sometimes. When we want to dilute something, we have to pay attention how much of the solvent should we add to our solute to make it less or more dilute or more or less strong. And mass percent's another way. So we talk about percentages of solutions. So there are lots of ways to do this. And like I said with the acid, I mean, like, okay, is it got a lot of that acid in there or is it mostly water? Okay, so the lower the molarity, the lower the amount of solute. So let's focus on, we're going to focus on 2 today, okay? And then I'm going to break it down. We did this in regular chemistry, but I want to make sure we understand 100%. And then we'll go into mass percent and dilution tomorrow. And we're also going to add another one called normality, okay? And I'm going to talk about that tomorrow. I just wrote that really, really badly, but okay, we'll talk about it later. But this is day 1 here, and then we're going to do this on day 2. All right, so we're going to divide it up a little bit so we have time to solve problems, and you guys are doing your activities in class, so we'll do that. We'll get a clue. Ha ha. All right, so what is, and I noticed sometimes these numbers went wrong, so I will fix them at some point, but just go with what we have now. What is the molarity? So again, very, very important to read the question carefully and look, because molarity and molality, there's only one little difference in their lettering. R and then an L. Every other letter is the same, so it's really hard, okay? But molarity, I know molality, is going to be moles of solute, so you got to find the moles of solute over liters of solution. So I already know that, so I might as well just go ahead and write it down as I go. So moles of solute, okay, over liters, molarity, even though that's got more L's, it doesn't sound great, okay, of solution. Now I abbreviate solution SOLN. That's the whole thing. Remember, a solution is a solvent and a solute together. The small part mixed with the big part, okay? And there could be multiple solutes, but in this case, we're going to read on of a 9.35 liter solution. What? Right there. And it says solution, and we do not have to add. If I had gotten an amount of a solute, an amount of a solvent, then I would have to add them together to get that total solution. So that's one of the biggest mistakes a lot of people make, is not reading really carefully and saying, oh, okay, that's solution, or is it solute and solvent, and we have to add to get the solution. And we're going to take that with 126.9 grams of KCl. So our solute is KCl, just so you know. Okay. And because why? Because it says we're going to take the grams of KCl and add it to the water. So usually when we're adding to something, that's the solute added to the solvent. All right. So all we have to do here is, this is not a hard one at all, except for, what do we notice here? Can I just plug 126.9 grams in? No. We want moles. Okay, so I got to do a little side problem real quick. So I'm going to take it down here and say, okay, I'm starting with 129 grams per 6.9 grams of KCl per gram. Sorry. I'm going to copy my unit, grams of KCl over mole, do it a mole of KCl. Of course, it's always 1 for the mole. Now I'm going to make it easier here. Again, you always want to show your work, but I'm going to show you that it's 39.10 for potassium and 35.45 for the chlorine. And that's enough to show your work. At least I know that you did do that. You have 2 decimal places, so when you add them together, you get 74.55. So again, I'm doing that kind of quickly because we know that stuff, right? So then we're going to take the 126.9, divide by the 74.55, and we're going to get 1.702 moles of KCl. But what are we actually going to use? We're going to plug it in up here, and actually it's going to go all the way up here, right? Okay, just to make it emphasis. How many sig figs? I had 4, so I'm good with the 4. So it is 1.702 moles of KCl, just making sure I know it's my solute. And then on the bottom here, I'm going to plug in my solution. And it already was done for me. So that is super duper nice, right? We're like, oh, okay, it's already there. So I did not have to do quite as much work as I could have had to do, all right? Now, we just divide and we're done. We have the moles and the liters and we're done. We got molarity now. and that is 0.182. Why am I stopping there? Because I'm going to 3 sig figs. You could write out more of the answer and then round later, but I'm just going to get to the point here. Okay? In an effort to make these shorter. So we can work on our stuff in class. All right, so that's molarity. Of course, guys, you could be asked, what's the volume if I have this molarity in this amount of grams or moles? Remember, gram and mole, interchangeable here, okay? Milliliter, liter, I give you the solute, I give you the solvent, you can add, okay? So make sure you realize all those different variations. I'm going to give you lots of practice and lots of different things to check yourself and check your work, okay? And the activities we do. Next question, of course, is what is the molality? Ooh, we got a molality. Okay. Now it's ironic. It's not liters this time, right? Why? Because some substances we cannot get a volume on. Okay, when we pour it in or something, maybe just as something that we can't put into a container. So we're going to mass it instead. So we can get a mass, but we can't get a volume. So this is based on volume, whereas this is based on mass. So that's the difference. Now there's another big difference. If you notice, it's solvent on the bottom. And we're not talking about the solution here. So the formula is completely different. So make sure you realize that. So when I wrote molality, first of all, also the unit for it is. Oh, and I just kind of slid past that because we did learn this last year, but that is the unit for molality. Molality is the unit. Okay, for molality. It's not only the unit, it is the variable. So if I were to write it right here, I wrote it as a variable. Those are not the same thing. So if you have a variable, it goes in front like that in an equation. It is not the same thing. You must put the unit after the value. And that molarity is actually equal to moles per liter. So it's just a shortcut. You could write moles per liter also. Now for molality, the unit is, okay, it is a lowercase m that is italicized or a lowercase m with a line over it. So they kind of mix it up, but it's not a capital anymore. It's lowercase for molality, okay? So I'll always even write the symbol that way. Molality equals, and again, that's the variable for it, moles of solute. So it's the same as it is for molarity on the top, but we're going to divide by the kilograms of the solvent. So we got to be careful here as we read, all right? So we're going to go through and we're going to pick out the givens here. Of a solution made by mixing, we're going to take 4.322 moles of calcium chloride. Hey, guys, in the water, that's more. Even though the grams and moles, you know that by the wording, that the calcium chloride is going to be our solute and the water is going to be our solvent. Now, that's not always the case, okay, guys? Sometimes water could be a solvent if it's a smaller amount. Maybe think about, like, I don't know, who knows? There's plenty of examples, but it doesn't matter right now. So we're just going to what? Plug this in because we don't have to change it. We didn't get grams this time, so we don't have to convert, so we can just go straight up. So again, watch your units. Sometimes you guys think, oh, I have to do more. Nope, not here this time. The time before in this question up here, yeah, we had grams, so we had to convert to moles before we could put it in there. But not to there. So now we're going to move on and we're going to look for the kilograms of solvent. What was I given? I was given that we have 683.9 grams. Now, you guys should all know that we have 1,000 grams equals 1 kilogram. So if we were to convert, all we do is divide by 1,000, which means move the decimal back 3. So it would be 0.6839 kilograms. I need kilograms there of the water. If you're not sure how to go from grams to kilograms or vice versa, you need to come ask questions directly, right? I don't want to waste everybody's time. So 4.322, but please come up, guys. I'm going to give you more of the numbers so we can go to the right amount of sig figs. You get 6.319637. How many sig figs? Well, we have 4 and 4. So we're going to go to 4. 1, 2, 3, 4. Now this one is a little trickier. That's why I wrote it out. The 6 rounds the 9, but the 9 has to roll. So that is 6.3. This becomes a 20. So the 19 becomes a 20. That's how you can also think about when you have to roll a 9 like that. But 6.320, you have to hold that place. And again, it is an italicized M, or you can write it as a M with a line over it. Just depends on how you want to do it. Those are both the same thing and both the same answer. So that's how you do molarity and molality. Again, any version. I just plugged these in and made these fairly simple that we just divided. But again, you can solve for any one of the variables in any equation, right? You have to know all the variables except one. So we could have been given the molality and the moles or the grams, and then asked to figure the kilograms of how much I would need to dissolve in it. Or we could look for the moles, the solute, etc. So in any of these situations, they can manipulate it to do lots of different types of problems. So we're going to practice and ask questions as we go. All right. See you in class.